Jai Hind students. We are studying our chapter number 4, Motion in a Plane, and this I am covering the projectile motion. It's a very special kind of motion, so I am making a separate video on it. And yes, I am your physics teacher. Till now, what we have studied was all about the motion in a straight line and motion in a plane. Motion in a plane like a raindrop problem, man and river problem, chore police problem, like that way I have discussed in the classroom also. So projectile motion, what do you mean by the projectile? If an object that is in flight after is being thrown or projected is called projectile. इसका सिंपल सा मतलब ये है कि सपोज करिए आपके पास एक वेट अ मिनट yes, suppose you are traveling in a plane and something is dropped from the plane. This will follow this trajectory because the plane is moving forward, and acceleration due to gravity will try to fall this object at the surface of the earth. So its motion will be like this way. It is a special kind of motion because simultaneously he is covering horizontal distance as well as a vertical distance. So if the both distances, horizontal as well as the vertical, is changing, that is termed as the projectile motion, whether it is dropped from somewhere or it is thrown to somewhere else. You have already seen about the kicks of football. There is a person who is standing on the ground, hits a football, and this ball follow like this trajectory. This special kind of trajectory is known as projectile motion. Now it can be understood as a result of two separate but simultaneously. This word is very important. Two separate as well as simultaneous occurring component of motion. First component is motion along the x-axis and the second component is motion along the y-axis. The component along the horizontal axis or the horizontal direction, or you might be called as x-axis, is without acceleration. Because throughout the motion its velocity is uniform, and in uniform velocity we can conclude that acceleration is not changing. Now, but in the direction of y-axis, the component along the vertical direction, that is y-axis, is with constant acceleration because it is always under the influence of gravity. So in this whole chapter, while dealing with the numericals and while dealing with the motion, I will always term as acceleration will be acceleration due to gravity, that is g, whose value will be 9.8 meter per second square. Got the point? Here is the decimal, and this direction of g will always be pointed towards the earth center, towards the center of earth, so it will be always taken as minus g. This is the assumption which I am making. Okay, that whenever we talk about the acceleration, you just have to put minus g. Okay, reason I have given to you. Now in our study, this is the second assumption. In our study, air resistance is negligible and the acceleration due to gravity is constant. It is not changing with the time, not changing with the position, not changing with the any other object over the entire path of the projectile. So what I have made three assumptions. First, acceleration due to gravity is constant, there is no air resistance, and it is always acting downward. Whether always it is acted towards the downward, not never you have heard about like such things that acceleration due to gravity is acting upward. So it was something silly. Okay, now let's moving forward. I am interested to know the displacement and velocity equation of a projectile motion. So just pay very careful attention. Okay, suppose that the particle is launched with a velocity v naught. Here is the velocity v naught from the origin I have launched a particle which is following a green color path like this way. You can see the path V naught that makes an angle theta naught from where with the x-axis, which means that this is the V naught velocity, initial velocity, which is at an angle of theta from the x-axis. Okay. Now, as seeing this component, I can say that this much distance is covered horizontally, while the maximum height of the object is this much. So can you see that whether he is uh, accomplishing a distance of horizontal as well as the vertical? So it is 2D motion. Now talking about the acceleration, acceleration in the x component will be 0. Okay, and the acceleration in the y will be, it is acting downward direction, so the acceleration will be minus g. Minus is something my sign convention for solving problems. I have already applied j cap and it is acting downward, which means minus j cap like this way. Okay, so here we write about the acceleration. Now the component of initial velocity. Velocity, as we all know, it's a vector quantity, so we can make a component of that velocity. First will be the horizontal component denoted as v naught x, whose value will be v naught cos theta. As I have told you in the classroom that the component will be v cos theta जो आपका थीटा एंगल के साथ होगा, and the vertical component will be, which is not with the theta, will be v naught sin theta. Talking about the initial position, what is the initial position? It is the origin as well. So as I know that x naught and y naught will be 0 0. Now putting this equation in the term s is equals to ut plus half et square, where s is the distance, u is the initial velocity, t is the time taken, plus half is the constant, a is the acceleration due to gravity, and t square. This is the very basic form of equation of motion, which you know about the second equation of motion name. Now my initial velocity is x naught plus v naught x t plus half axt square. This x naught means if my initial position is not from the origin, so you can take it as 0, but if there is a condition that yes, I have started it from the origin, so there is nothing use of this x naught. So in short, I can write as my displacement equation in terms of v naught xt will be equal to v naught cos theta t. Where this acceleration is going? This is 0 because of this is the component of acceleration in the horizontal axis. Horizontal axis पर acceleration due to gravity का component 0 है. That's why it is 0. So the distance covered या displacement covered in the horizontal direction will be given by this equation. X is equals to v naught x t, where v naught x is the horizontal component, which could be given as v naught cos theta t. Similarly, in the y direction, I can say that yes, this v naught will be 0 if I am starting from the initial position, and the component of initial velocity in the direction of y is v naught sin theta t. Just I have put it here. This positive sign will be changed into the negative one. Why? Because direction of acceleration is towards the downward, and I am taking my reference point downward negative, upward positive. So y is equals to v naught sin theta t minus half gt square. Now the component of velocity at the time t, so we will apply a first equation of motion. V is equals to u plus at, where a is the acceleration due to gravity, u is the initial velocity, and this v is the final velocity. So vx component will be v naught x plus axt, as the acceleration due to gravity in the horizontal direction is 0. This term will again be 0, and vx will be equals to v naught cos theta naught. Similarly, in the y direction, Vy is equals to V naught y plus Ayt, which is nothing but the format of V is equals to U plus At. Just substitute the value, you will get the point as Vy is equals to V naught sine theta naught minus Gt. Okay, moving forward. Now, what will be the magnitude of the velocity? The magnitude of velocity of the projectile at an instant t could be given as the summation of the horizontal components plus vertical component. This you have studied, and if I take it under root like this way, just this component is the total component along the x and y direction. So this is given by this equation, and the angle could be written as V naught sine theta naught minus Gt upon V naught cos theta naught. So the horizontal component here, this is the 2 point which you have to remember or take into the consideration while solving numerical. The horizontal component of the velocity remains constant throughout the motion, but the vertical component will reduce to 0 at the peak, because at the peak point velocity will be 0, and from there only it is going to downward direction and path, and again increases in the opposite direction. So what does it mean? Initially, when you apply force or give some velocity to this ball, its velocity is continuously decreasing in this manner, and at the maximum height its velocity will be 0. Again he is trying to regain its velocity or increases its velocity. So this was the fundamental basic concepts of projectile motion. In the next video we will calculate its time period, its range, and the angle theta. So the trajectory equation like this way. I am not covering this in this single video because it will become very hectic and lengthy also. So thank you and Jai Hind. Surely you will see the second video. Thank you.